So in this problem, we're going to be finding the local extrema of f of x equals x cubed over 3 minus x using the second derivative test. So when we're doing the second derivative test, our first step is to find the first and second derivative of the function. So we'll start with f prime of x, which in this case, if we multiply this exponent out front and subtract 1 from it, we'll get 3x squared over 3 minus the derivative of x is just 1. And our 3's will cancel out, leaving us with x squared minus 1. Now we want to find our second derivative. And remember, when you're finding your second derivative, it literally just means find the derivative of your first derivative. So going back to this x squared minus 1, the derivative of x squared is 2x, and the derivative of minus 1 is just 0. Once we do this, we then need to find our critical numbers. But we only need the critical numbers such that f prime of x is equal to 0. We don't want the ones where the first derivative is undefined or does not exist. So we're going to take our x squared minus 1 and we're going to set it equal to 0 and solve for x. So we're going to factor this. X squared minus 1 is a difference of squares. We need two numbers that multiply to give us negative 1 and add up to get us 0. That's positive 1 and negative 1. So now that this is factored, we can set each factor equal to 0. We get x plus 1 equals 0. And x minus 1 equals 0, which leaves us with x equals negative 1 and x equals positive 1. Once we've done this, we now need to make sure that these are critical numbers, because as of right now, they are partition numbers. So to find out if they're critical numbers, we go back to the original function, x cubed over 3 minus x, and we plug them in. So we're going to find f of negative 1 and f of positive 1. When we plug negative 1 in, we get negative 1. We get negative 1 to the third power over 3 minus negative 1, which gives you negative 1 over 3 plus 1, or 2/3. 2/3 is a real number, so negative 1 is a critical number. Now we'll check if our partition number of x equals 1 is a critical number. So we'll plug 1 in, which gives us 1 cubed over 3 minus positive 1. That's going to give us 1/3 minus 1, which is negative 2/3. Again, this is a real number, so this gives us another critical number. Negative 1 and positive 1 are both critical numbers. Once we've done all of this, the second derivative test then says that we literally have to test the second derivative. We need to take f double prime of x equals 2x, and we need to plug each of our critical numbers into the second derivative. So we're going to find f double prime of negative 1 as well as f double prime of positive 1. When you plug negative 1 into 2x, you get 2 times negative 1, which is -2. And all we care about is the fact that this is less than 0. Because this is less than 0, we know that this is concave down. Whenever your second derivative is negative, you have a concave down on that critical number, which means we're dealing with a local max. Likewise, f double prime of 1 is 2 times +1, which is 2. All we care about is the fact that that is greater than 0. Since it's greater than 0, it means that it's concave up. Remember, concave up looks like a smiley face. So we're dealing with a local minimum. Now we just want to label what each of these points are. So we'll start with the critical number -1. We said that -1 has a y value over here of 2/3. So -1, 2/3 is a local maximum. And now we'll pick our critical number of 1. 1, -2/3 is a local minimum. And this gives us all of our relative or local extrema using the second derivative test.